Hello, class. This is Mr. Eggleston, and this is the Check Your Understanding for Lesson 7.1 for Algebra 1, Quadratic Growth. The first question is I got the hiccups. Cindy is doing a 30-day jumping jack challenge. On the first day, she does 5 jumping jacks. On the second day, she does 10 jumping jacks. On the third day, she does 15 jumping jacks. This pattern continues. So the pattern is that you start off with 5, then 10, then 15, and then 20, and so forth. Okay? Is fj of n, which is the number of jumping jacks, a linear function, a quadratic function, or neither? Well, it's linear. J of n is linear because we are adding 5 each day. Okay? Each day we are adding 5 more jumping jacks. Done. All right? So because we're adding 5 each day, it has a constant rate of change. It has a constant rate of change. Let T of n represent the total number of jumping jacks Cindy has done by the nth day of the challenge. Is T of n a linear function, a quadratic function, or neither? Well, that means on the first day you did 5. On the second day she did 10, so the total would be 15. On the third day it would be 15 more, so that would be 30. So we're just adding, right? We're adding 10 plus 5 gives you 15. 15 plus 15 gives you 30. 30 plus 20 is 50, and so forth. All right? And so we have 5, 15, 30, 50, and heck, we'll even go as far as 75. All right? So, is it a linear function? If it's a linear function, that means it would have a constant first difference. So 15 minus 5 is 10. 30 minus 15 is 15. 50 minus 30 is 20. 75. 75. So we got 10, 15, 20. 75 minus 50 is 25. And then if you look at this is the first difference, the difference of the original values first. If we look at the second difference, the differences of the differences, you would see that we have 15 minus 10 is 5, 20 minus 15 is 5, and 25 minus 20 is 5. Notice the second difference is constant. So T of n is quadratic because it has a constant second difference, the difference of the differences, of the first differences. Okay, so it's quadratic in nature. All right. Oh, and the constant difference has a constant second difference, which equals 5 each time. All right, they say complete the table of values. If x is negative 2, all right, so negative 2 plus 5 is 3 times 2 times negative 2 is negative 4 minus 3 is negative 7. That equals negative 21. When x is negative 1, that's going to be 4 times negative 2 minus 3 is negative 5, and that's negative 20. When x is 0, that's going to be 5 times a negative 3. which is negative, negative 15. When x is 1, that's going to be 6 times a negative 1, which is negative 6. And when x is 7, or 2, excuse me, it's going to be 7 times 4 minus 3, which is 1, which equals 7. And if you look at these, you see the common difference is you go from negative 21 to negative 20. We're adding 1. Negative 20 to negative 15, we are adding 5. Negative 15 to negative 6, we are adding 9. And negative 6 to 7 is we are adding 13. Okay. If we look at this, the second difference, we add 4. We are adding 4. We are adding 4. So it has a common second difference. So since the second difference is constant, we know that this must be a quadratic. So now we're going to rewrite. This is a kind of a key step. You should know how to multiply binomials together. Easiest way is to make a box like this. A square that has 1, 2 rows and our columns and 1, 2 rows. So what we've put here is the product of 2x and x. 2x times x is 2x squared. Then what goes here is going to be 2x times 5. 2x times 5 is 10x. And we just complete this box. X times a negative 3 is negative 3x. And lastly, negative 3 times 5 gives you a negative 15. All right, so what's nice about multiplying, this is basically what we're doing is distributing x plus 5 twice. Or we distribute x against everything on the back end, so x times 2x, x times negative 3. And then 5 times 2x, 5 times negative 3. A lot of you might have seen this previously and heard the phrase FOIL. Okay, first, outer, inner, last, which works great, but I'm being serious with you. The easiest way to multiply binomials is by making a square. And knowing that what goes in each of the 4 pieces here is the product of the two terms here, x and 2x, 2x squared. 2x times 5, 10x. Negative 3 times x, negative 3x. And negative 3 times 5, negative 15. What's nice when we do it this way, usually if you go down this back diagonal, those are the like terms. So this comes out to be 2x squared. And then you have to add. What is 10x plus a negative 3x? What's 10 plus negative 3? That's going to be 7x. And then negative 3 times 5 gives you the negative 15. And here's the product of the two binomials. All right? Give at least 2 clues as to why g of x is a quadratic function. Well, one clue is that g of x is the product of 2 linear factors. And that is the definition of a quadratic. Also, the table shows a constant second difference, and that's the other indication. Okay. I also wanted to point out, since now you've seen this box method of multiplying, we can show why this last one right here, this one, actually turns out to equal that. All right? You do that because you have to, n plus 1 squared literally means n plus 1 times n plus 1. N plus 1, n plus 1. This is that box method. All right? N times n gives you n squared. N times 1 gives you 1n, or n. Same thing on the second one. 1 times n gives you 1n. And then lastly, 1 times 1 gives you 1. So n plus 1 squared equals n squared plus 2n plus 1, which is almost the same as this blue piece, except for we have this plus 1 sitting there, so we subtract the 1 to get rid of it. So if we subtract 1, then they cancel out, and you'd be left with the blue n squared plus 2n. So this is why this is the same thing as that. All right? I just wanted to point that out. All right? And there you go. I hope that makes sense. Have a good day.